think my screen is visible? Yes.
Yes, sir.
Okay. Mm, okay. So today we'll discuss about this classification of transistors. What are these transistors? Okay. May I know what is transistor basically first before going into the transistors, classification of transistors. So what is transistor?
It's an electronic switch.
How the name came? Transistor. Transistor. Transistor is nothing but anyone. Transistor is nothing but transfer of resistance. Transfer plus resistance. Okay. So transfer plus resistance means so basically you are transferring from which resistance. So we have Ohm's law. V equal to what? IR. Okay. V equal to IR. So from this R equal to what? V by I. Okay. So or I equal to what? V by R. Okay, V by R. Okay, so basically this transistor is acting as you already studied this transistor is acting as an amplifier as well as switch. Okay, so what is amplifier? Amplifier is nothing but it is amplifying low amplitude signal into high amplitude signal. Okay, so means what happening, it is amplifying low current. Okay, low current, so low current, so we can say to high current. Okay, high current, so that means if you see the resistance and current both are inversely proportional. So that means the whatever the transistor you have, it should be it should have high input impedance, and just it should have low input impedance, then only it will act as transistor. So it is transferring from high resistance to low resistance, high resistance to low resistance. Okay, so low resistance. Okay, so basically like we already seen diode is how many terminal device? Diode is a two terminal device. So diode is a two terminal device. You have anode and cathode. Okay, this is PN junction diode. Okay, so that means one of the disadvantage of using this diode is basically we have only like uh, two parameters are there. That means like if you see for this one, there is a diode current and there is a diode voltage. Only two parameters are there. Okay, so what the scientists had decided, so they invented the three terminal device. So in the three terminal device, by varying the one terminal, we can vary the other terminal. Okay, so like you already studied about this BJT. Okay, BJT, so this is BJT. So BJT is how many terminal device? Three terminal device, bipolar junction transistor. So bipolar junction transistor means the current is due to what? Both majority and minority carriers. Okay, so just for understanding purpose, just I'm telling BJT, but here in VLSI we are not studying BJT. So you have input terminal base, and this is collector, and this is emitter. Okay, so here you have what? This is current IC. So collector current equal to, you got beta into IB, no? So then that means function, that means collector, I can say that collector current equal to function of base current. So from this I can say that BJT is which device? Current controlled device. Current controlled device. Okay, so current controlled device means what? By controlling the input current, by varying the input current, I am varying the input current is base current, I am varying the output current, I'm varying the output current. Okay, so so this is the BJT. So current is due to both electrons and holes. Okay, so why we are not preferring means the noise will be more if you use this BJT. The noise means what? Adding unwanted signals, the noise will be more for the BJT. Okay, so next come with this is nothing but bipolar device. Bipolar device. Bipolar device means the current is due to both majority carriers and minority carriers, both electrons and holes. You already studied. There is PNP transistor, NPN transistor. Okay, so these two transistor, common base, common emitter, common collector. This you studied. So next you have FET. Next you have FET. FET is a unipolar device. FET is what? FET is a unipolar device. Okay. So unipolar means what? Current is due to only either majority carriers. So
Also,
that means
like,
either electrons or holes.
oh,
Okay. So here if you see, so that means uh, here there are three terminals are there. This is nothing but gate, and this is what drain. Okay, and this is source. Okay, so why this is different means like base and gate both are same, like base, the meaning of base, gate, which will allow. Okay, that is nothing but gate, and drain, collector means what? Which will collect. Okay, which will collect. Suppose drain also same thing. Suppose if you consider like uh, so water is coming from the source. Okay, it's like emitter or source. Okay, sun will give the light. Okay, sun will emit the light. Okay, emit the light, like that. Sun will, so source will source the light, and water is coming, and where it is going? It is draining through this sink. Through the sink the water is draining. Okay, so that means source is giving the some electrons or holes. So from the drain it is going. Okay, so that is nothing but based on this they given the terminals gate. So this is gate, drain, and next one this is source. Okay, this is source. So here what happens? You are applying some voltage, VGS. Okay, gate to source voltage, you are applying voltage, so that you are getting the drain current ID. ID is function of what? VDS. ID is function of VDS. From this I can say that FET is which device? Voltage control device. So that means ID, so the drain current is a function of VGS, gate to source voltage. By varying the input voltage, you are getting the output current. Okay, so that FET is a voltage control device. FET is a voltage control device. Okay, voltage control device. Okay, so this is about BJT and FET, the difference between BJT and FET. Okay, is it fine? What is transistor? So how many types of transistors are there, and what is the difference between BJT and FET? Uh, did you understood, or shall I move forward?
yes, sir.
Next use. So next, suppose transistor is there. So transistor you already know. So transistor is nothing but transfer as resistance. So classification of transistors. Okay, transistor classification. So classification of transistors if you take. So here you have uh, BJT. BJT means what? Bipolar junction transistor. Bipolar junction transistor. Bipolar junction transistor. Okay, so again BJT there are two types are there. So what are those? PNP transistor,
NP.
NPN transistor. PNP transistor, NPN transistor. Okay, NPN transistor. Okay, and next you have FET, field effect transistor. Field effect transistor. Field effect transistor. So this is nothing but FET, field effect transistor. So again in field effect transistor there are two types are there. Those are JFET and MOSFET. JFET is nothing but what? Junction field effect transistor. Junction field effect transistor. Okay, and MOSFET. MOSFET is also called as IGFET also. Okay, MOSFET. MOSFET is nothing but metal oxide semiconductor
Field effect transistor.
field effect transistor. Semiconductor field effect transistor. Okay, so that means a junction field effect transistor. Here again this is classified as depletion type only. Okay, this is nothing but depletion type only. So what is meant by depletion? Depletion means what? Already there is exist a channel. There exists a channel. Okay, channel means what? Suppose like if you consider, suppose in communication, there is a wireless communication. Wireless communication, what is a channel? Free space is nothing but a channel. Okay, suppose there is a optical fiber communication. What is a channel? There is a cable called light. Light is a channel. So that the like the data, whatever the data is there, that is transmitting through the channel. Suppose if you take a pipe, so in the pipe water will flow. So what is the channel? Pipe is a channel. So like that, channel is nothing but it's a thin, we can call as a layer. In this layer, either electrons or holes will move. It's a medium. It's a medium. In this, the charge carriers will move. Okay, so channel already exists. Okay, is nothing but depletion type MOSFET. Okay, depletion type JFET. And here again there are two types: N channel, and next P channel. What is N channel? That means in channel there are electrons are flowing, majority carriers. What are the majority carriers? Electrons. Okay, here P channel means holes are the majority carriers, holes are moving, that is P channel. Okay, and next in MOSFET there are two types are there. So depletion means what? Already channel exists. Again there are two types, N channel, and next you have P channel, N channel and P channel. And enhancement with what? Channel does not exist. By default, when it is manufacturing, channel does not exist. We need to develop the channel by applying positive gate voltage. Positive, so channel, no channel. Okay, here depletion means what? Channel exist. Okay, so we need to apply some positive gate to source voltage if it is a N channel MOSFET, and negative gate to source voltage if it is P channel. So you need to apply input gate to source voltage, so that we need to develop the channel. Okay, so here again there are two types, N channel, and next you have P channel. N channel and P channel. Okay, so these are the difference between different classification of transistors about BJT and FET. So we are not studying this in VLSI, and we are not studying this with JFET in the VLSI. Why we are not studying, I will tell you. We are studying MOSFET. Okay, so we are studying MOSFET, that too we are using this MOSFET, that too we are using enhancement N channel MOSFET. Okay, P channel also we are using. In CMOS, complementary metal oxide semiconductor, we use PMOS as pull up. That means what? P channel enhancement MOSFET. Okay, N channel as pull down. Okay, N channel as pull down means what? NMOS. Okay, NMOS. Okay, we are using. Okay, N channel enhancement MOSFET we are using. Okay, is it fine? Give response. Any doubt in this?
Yes, sir, clear.
Yeah. 1 second. It's full rain. Just cool it. Yeah. So this is about the classification of transistor. Okay, classification of transistor. So now I will tell you why we are not using JFET, why we are using only MOSFET. Okay, in the VLSI, why we are not using JFET and why we are using concept of field effect. Okay, that is nothing but concept of field effect. Okay, so this is the classification. What about others? Is it fine? Do you understood? Give response so that I will move forward. Okay. Next you see. So concept of field effect. What is this concept of field effect? Okay. So concept of field effect is concept of field effect. Concept of field effect is so you know that R equal to what? Rho L by A, no? R equal to what? Rho L by A. And R is the resistance. Conductance is the reciprocal of what? Resistance. Conductance is reciprocal of resistance. So from here, conductance equal to what? Conductance equal to 1 by rho L by A. Rho L by A. So this is conductance equal to what? A by rho L. A by rho L. Okay. So here you got one equation in the semiconductor physics that is sigma, in which current that is drift current. Drift current, you got this equation. Conductance equal to what? NQ mu, you got, no? NQ mu n, NQ mu n plus PQ mu p, you got, no? Okay. So from this I can write that is conductance equal to, in general, with respect to electrons, NQ mu. NQ mu. Okay. So conductance, conductivity, this is conductivity. Okay. This is nothing but conductivity. Conductivity and resistivity is reciprocal with each other. Okay. So from this, rho equal to 1 by sigma resistivity. Okay. Resistivity equal to what? 1 by NQ mu, I can write. Okay. So here R is nothing but resistance. G is nothing but conductance, and sigma is nothing but conductivity, and conductivity. Okay. Conductivity. And rho is nothing but resistivity. Okay. So if you substitute this resistivity value, A by what is the formula? So A by NQ, one second. From this I can write this is what? Sigma by L, no? Can I write? Why? Because sigma equal to what? 1 by rho, no? Sigma equal to 1 by rho. Okay. So from this G equal to what? G equal to sigma A by L. Sigma A by L. Okay. You substitute G equal to what is sigma? What is sigma? This sigma equal to NQ mu A by L. Okay. NQ mu A by L. Okay.